In this question, we want to find the limit of x times the natural log of x as x approaches 0 from the positive side. So first step, let's substitute x goes to 0 to our function. And we would get 0 times the natural log of x as x goes to 0 will give us negative infinity. So now we have a form of 0 times negative infinity, which in calculus is called an indeterminate form. An indeterminate form just means your answer or your limit is not set yet. These forms suggest that further analysis or algebraic manipulation is needed to find the limit. So let me list the common indeterminate forms. So we have 0 over 0, infinity over infinity, 0 times infinity, infinity minus infinity, 0 to the 0's power, infinity to the 0's power, and 1 to the infinity's power. For the first two cases, the most common way to solve is by using L'Hopital's rule, which is taking the derivative of both the denominator and numerator and then plug in the value again. And for these cases, we cannot using L'Hopital's rule directly, and often a rewrite of the function is needed. And in our case, I will show you how to solve 0 times infinity format. And for the last three cases, because it evolves exponential, so often taking the logarithm of the function is needed in order to find limit. So the key for resolving this indeterminate form is we want to rewrite the product x times ln of x as a fraction, and this would allow us to apply L'Hopital's rules. In this case, if we substitute x approaches 0 again, on top of the fraction we get negative infinity, and on the bottom we would get infinity. So we have infinity over infinity form, which we would want to use L'Hopital's rules to solve. And L'Hopital's rule states that if we have a limit that have a form such as 0 over 0 or infinity over infinity, then we can take the derivative of both the denominator and the numerator separately, and that should give us the same limit value as our original equation. And in our case, we have so we take derivative of both top and bottom, and we get 1 over x over minus 1 over x squared. To simplify the function, we would get negative, and then both on top and bottom times x squared, we would get negative x. And we know x approaches 0, so negative x is also going to be 0. So in here, we have solved the limit of x times natural log of x, and the limit goes to 0. The key for solving this type of question is to rewrite the product form to a fraction form so that we can apply L'Hopital's rule directly.